On today's episode, we are getting into the latest space news, including India wins the race to the lunar South Pole, SpaceX finishes pre-flight testing with a full-duration static fire of Booster 9, and the ESA struggles with their orbital debris removal efforts. On August 23rd, India's Chandrayaan-3 vehicle successfully touched down on the moon's south pole, making India the fourth country to have ever landed a vehicle on the lunar surface and the first country to do so at the lunar South Pole. The Chandrayaan-3 made a 19-minute controlled descent and landed at 8:32 a.m. Eastern Time to a background of cheers and celebration from a very deserving Indian ground crew. The main Vikram lander then was forced to wait a few hours for the dust from the powered landing to settle before deploying its Pragyan rover and beginning India's first lunar exploration in earnest, with ISRO ground crews reporting that the lander and rover payloads were both operating normally. Two of the three main objectives of the Chandrayaan-3 mission were complete. Getting the lander safely onto the moon was the first objective, and demonstrating their rover's abilities on the lunar surface was the second. The third is the real reason India's ISRO sent their lander to the moon's south pole in the first place. They are testing the local materials. The Vikram lander is equipped with a thermal sensor to measure the temperatures and the local soil's ability to hold heat. It also has a seismometer to test for moonquakes and a Langmuir probe to check for plasma density close to the surface. The moon doesn't have an atmosphere, so the regolith can hold a weak charge that collects plasma, something we can't really observe anywhere else. The six-wheeled Pragyan rover, meanwhile, has a little X-ray spectrometer to get a close-up look at the composition of the lunar regolith, and a laser-based spectroscope to get a more elemental breakdown of the soil and rocks. And all of this effort is just for a sprint of science work. One lunar day, or 14 Earth days, until the South Pole is tilted away from the sun and the darkness freezes both the lander and its rover. The longest part of the mission was started before Chandrayaan-3 even launched. The Chandrayaan-2 orbiter has been silently flying circles around the moon, taking photographs of the site and using its array of instruments to do everything from map the terrain to scan for water molecules. The Chandrayaan-2 orbiter is a subtle reminder of how much the ISRO had to go through in order to stick the landing with their third mission. A couple of others have tried and failed recently to land on the moon. iSpace's Hakuto-R and Russia's Luna 25 come to mind, but no one has made it since China landed their Chang'e 5 vehicle in 2020. And that's because it is way harder than even some space agencies think it is to land something safely on the moon. There have only been 4 countries ever to do it: the United States, the former USSR, China, and now India. And even they lost their Chandrayaan-2 mission before they managed to get their lander safely to the surface. When Chandrayaan-2 arrived in orbit around the moon, the Vikram lander for that mission separated from the orbiter and made its way to the surface. Partway down, the vehicle's trajectory started to drift, it suffered a communications failure, and that was it. Chandrayaan-2 had suffered a software glitch that stopped the lander from braking at the appropriate altitudes, a problem they addressed in the Chandrayaan-3 vehicle. And that's the real reason India's vehicle made it to the surface, while iSpace and Russia's landers didn't. They had the benefit of learning from their mistakes. The report from the Chandrayaan-2 lander showed that one of their engines was slightly more powerful than the others, causing the computer to miscalculate. They fixed that. The report also showed that the main engine throttle wasn't what the fuel computer thought it was supposed to be, so that also had to be fixed. The ISRO team finished their report on November of 2019 and went through it line by line to make sure their third mission would land properly. Unlike Luna 25, Chandrayaan-3 took a month-long trajectory to save fuel, and they did not rush the landing. And on top of all this, they can now add their data and findings to NASA's knowledge for the Artemis missions. So this isn't just a success for India, it's a success for the world. The ISRO team worked hard and smart for this win and deserve some serious kudos. A second and potentially final static fire test for Booster 9 was successfully completed at Starbase Boca Chica on August 25th. The booster's full complement of 33 Raptor engines rocked the test stand for a full 6 seconds, and even though 2 of the engines shut down early, it was still much more productive than the previous static fire on August 6th, which saw the SpaceX team shut down the whole rig after about 2 seconds as engines began going cold. Just like last time, we got some amazing shots from the SpaceX team showing the test from various angles, but of particular note is the deluge system containing the shock waves of those 33 engines firing. You can see the blast vibrating the steam, but while 3,600 tons of force were enough to instantly vaporize the water coming out of the deluge system, it wasn't enough to overcome the system completely, and no additional debris or dust seems to have been kicked up. To go along with that, it seems like there was little to no damage done to the steel plate directly below the booster either, making this an entirely successful proof of concept test for the deluge system. And even more importantly, this test marks what is likely the final trial for Booster 9 before it is stacked for a test flight. They've done pressure tests, spin-primed the pumps, static-fired the vehicle twice, and added the new interstage vent ring on the top for the hot staging attempt during the next test flight. It's hard to imagine anything else that SpaceX could do, unless, of course, the FAA surprises them. They still haven't publicized any findings from their investigation of the April 20th flight test that ended poorly, but that's hardly their fault. SpaceX submitted their final mishap report to the FAA on August 15th. This is the internal report that a company has to file with the administration before any judgments can be made. The FAA confirmed that they are now reviewing the report and would be informing SpaceX about the corrective actions they'll have to take once that process is finished, so this might take a bit more time. The FAA does tend to be thorough with explosive mishaps especially, but it's not like they won't be giving SpaceX a heads up either. Back when the administration was preparing their environmental assessment ahead of granting SpaceX their license to test the Starship prototype, we learned that this project was important enough for the FAA to be working directly with the launch company in order to satisfy the more than 75 actions needed to lessen the environmental impact. Which all makes sense, as SpaceX is on a strict timeline to get Starship running. The Super Heavy launch vehicle is already planned for a slew of government missions, not least of which being Artemis 3 in 2025. So it's a good possibility that the FAA would have some communication at least with the company about what they need to fix in order for the launch schedules to stay where they are. What we can say for sure is that the SpaceX team spent their time wisely. Booster 9 seems pretty much ready to go, and the launch facility's repairs and upgrades are all functioning incredibly well. With any luck, SpaceX has been proactive enough to minimize the amount of work they'll have to do for the FAA to give them flight authority again. It might be a week or several, but either way, Booster 9 is ready to fly. The European Space Agency has an ambitious new plan to clean low Earth orbit of rocket debris, but the execution of this plan is already proving to be tricky. In 2020, the ESA contracted a new Swiss company called ClearSpace SA to build a vehicle that would be used in the first ever space debris cleanup mission, ClearSpace 1. The goal was for this vehicle to demonstrate a procedure for deorbiting debris via 4 tentacle-like arms. Using LiDAR, radar, and a series of cameras, the ClearSpace 1 vehicle is designed to latch onto a target piece of debris and deorbit in a safe trajectory, and all of it is designed to be automated. The intended target for this mission was an old 2-meter diameter payload adapter from the 2013 Vega VV02 mission, coming in at about 113 kilograms. Payload adapters are typically mounting points that allow payloads, in this case the Proba-V satellite, to be attached to a rocket's upper stage. Suffice to say, this thing is a bit big. Some of you might have caught our use of the word "was" back there, and that's because on August 10th, the US Space Force informed the ESA mission leaders that their monitoring equipment had detected some new debris in the vicinity of their target, meaning it had likely been struck and damaged by another piece of debris. Smaller pieces of garbage smash into each other fairly regularly in orbit, and so as long as they don't have significant mass, there's generally little cause for alarm. The big problem in this case is that not only is the entire mission thrown off by this trajectory-altering collision, but now there are even more pieces of trash floating around. The ClearSpace 1 mission is slated for liftoff on a Vega C rocket in 2026, which is plenty of time to find another target and adjust the calculations. But this collision emphasizes how difficult this decluttering program is going to be and how important it is that we get started. More parts and defunct satellites means more chances of collisions, which causes more debris, and this puts our stations and active satellites at risk and makes it harder to launch new vehicles. The ESA is simply the first agency to take this stance, backing it up with a zero-debris agreement with their partner companies at the Paris Air Show back in June. Partners like Airbus, OHB, and Thales Alenia have all signed on to the as-yet-undisclosed charter, which will reportedly hold them and the ESA to the goal of eliminating junk parts once detached in orbit. It's the best way to start making our orbit safe, and the ESA is hardly alone in recognizing the danger. In late 2022, the American Federal Communications Commission updated their laws on debris and satellites to force orbital operators to include a plan to deorbit their trash or dead satellites within 5 years of launch, with the option of renewing your license, of course. But while some experiments have been conducted, like the 2022 NanoRacks cutting experiment, progress has been slow. Space debris is uncontrollable and dangerous. One wrong move could turn a collector satellite into fresh debris on its own. However, this is a necessary effort. We have several new space stations starting within this decade, not to mention fresh attempts at manufacturing in low Earth orbit, so we need a safer sphere of influence, and that starts with missions like Clear Space One. Now, they just need a new target. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long-form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.